This is the third video to section 2.2, where we'll be discussing frequency polygons and time series graphs. If we look at example 6, we'll see that life expectancies are given for women between certain age intervals, and we want to make a frequency polygon. What we first must do is we have to take each interval here and find the midpoint. In order to find the midpoint, you add the lower bound plus the upper bound, and you divide that by 2. So for the first interval, and 104 divided by 2 is 52. We'll continue doing that for each of these intervals here. We'll add up the lower bound to the upper bound and divide by 2. And when you do that, you should get the following as your midpoints. Once we have our midpoint made, we are going to go ahead and construct our x and y axis. Next, go ahead and label your axis. And after you label your axis, go ahead and identify your increments on each axis. We're going to label the x-axis with our midpoints. While we're doing this, keep in mind that a frequency polygon looks an awful lot like a line graph. Now that we have our axis made, let's go ahead and plot these points. So at the midpoint of 52, we have a frequency of 3, and at 59, we have a frequency of 3, and we continue with this. Once you have the line, the dots plotted, you go ahead and connect each dot with a line. Now, a frequency polygon always has to begin and end on our x-axis. So you'll want to go ahead and connect these at the very bottom here. And notice this does certainly look a lot like a line graph. If we go down to the next problem, this time they gave us the same type of frequency table, but for the life expectancy of men. So once again, we'll find the midpoint of each of these intervals for the men. And since the intervals are the same for both the men and the women, the midpoints will be the same as well, which means we can use our graph above, but let's use a different color to draw in the points for men. And once again, we go ahead and we connect each dot with a line. And remember that our frequency polygons are supposed to begin and end, touching the x-axis. We might also want to place here that red represents our men, whereas the green line represents our women. And of course, don't forget our title either. And there we have it. We have our frequency polygon. Letter C asks us to discuss the shape of the distribution. And here we'll notice that our data is skewed more toward the left, whereas the life expectancies, the majority of them, seem to occur off at the right here. So we have skewed left for both of these. It doesn't look like we have any outliers here. Remember, an outlier means a point that falls very far away from our common data, and all of our smallest values and largest values, they still fall within an appropriate range. Also, if we were to look at the averages for men and women, the average life expectancy from this sample is 71.6 years for women, whereas it's 73.4 years for men. Let's go to our next page for the time series graph. Taking a look at example 7, we'll see that we are given a table for the city of Detroit, Michigan during a certain time period with the number of homicides per 100,000 citizens and the number of full-time police officers per 100,000 citizens. Once again, let's start out making our X and Y axis and labeling it. And let's also go ahead and put in our type. And then let's start out by plotting some of our points for police first. And we'll let the police be blue. And once we have the points plotted, we go ahead and connect them with lines. So when we have this, we'll see that there's quite an increase, it looks like, after 1967 in the number of police officers. Now let's go ahead and in a different color graph our homicides. Let's use the color red. We'll go ahead and plot our points. Since this is a double time series graph, we'll plot them on the exact same graph. And once we have the points, we'll go ahead and we'll connect those points with the lines as well. And here we go, we have our time series graph. For letter B, they ask us, which variable increased the fastest? Well, starting in about 1967, it looks like both the number of police officers and the number of homicides takes an increase. But if you look at our blue line, it's increasing much faster than our red line is increasing. So which variable is increasing the fastest? That would be the police staff levels. And that's because the line is growing faster at the same time as the line for the homicides. For letter C, they ask us, did Detroit's increase in police officers have an impact on the murder rate? And truthfully, it's hard to see. We can see that there's an increase in police. We can see that there's an increase in the murder rate. Now, would the murder rate have been even higher if the police officers force hadn't been added to? That's hard to say. But perhaps the increased rate of homicides impacted the level of police staffing. So I would think that would be our best bet in this case. That is the end of our section 2.2 videos.